Welcome back to the Caribou Data Science channel. It's the time of evening now when we do the random states analysis for COVID-19. So we go out first, we go out and we're going to select a random state to analyze. And the winner is New Jersey. Alrighty now. Let's just open up RStudio here. And I'll have links to both the code, the data, the playlist for the random states playlist, and also a link to my Caribou Data Science YouTube channel for you to subscribe to. Okay, let's come back over here. Random states, open a project. And here's last night's project. So we'll do another markdown today. Random states. And tonight is New Jersey. All right. So we're going to save this. Call this New Jersey. RMD. Okay, now let's go get our data. The data is kept on GitHub. Once again, we're using the New York Times data set. We'll simply download the repository here. Download zip. And we're just going to update the data here today. And just as a reminder, I am using a GitHub repository to manage all my code. The link to that will also be in the description below. So they can see the Oklahoma from last night and the Oklahoma data. Look at this. So we're going to be looking at the state's data. Again, this data is a cumulative total, so it means it's the total number of cases through death from January up until the 21st in this case. Don't need this. And what we have to do is this. We have to calculate cases minus previous day case. I'm going to put a 0 up there also just for convenience. Then we drag this down. Oh, wait. It's embarrassing. I forgot to pull out the data we needed for New Jersey. New Jersey. No wonder the numbers aren't making any sense. That's all right. Get rid of that. Let's come back over here since this is all New Jersey. Let's just make sure we are sorting by date. Now we're going to come down here and recalculate New Jersey's cumulative or daily cases. Cases and deaths by day. That's good. Like I say, the only thing that matters is that we get the results we're looking for. Okay, so where are we here? I don't think I used any libraries last night, did I? I am going to change the size of the figures to. Okay, let's begin as we do all. New Jersey. Okay. I didn't mean to introduce this tonight, but hey, take a second look at New Jersey. Wow. Okay. That's strange. Okay, now we're all right then. So the only thing we need to do here is date. Let's So let's just run this and run this. Just check our date format. Oh, let's do this. Year, month, day. And as we like to do, let's start with a plot of. Now, you know the drill. It's very simple plots. You know what? Let's say let's you know what let's do here. Let's do one more thing. Oh, okay. One more thing. And really, I forgot to. Wait. Oh, this isn't looking right, is it? Now let's come back up here and see what we actually got. Oh, date. Very good. Now, so first, let's do the cumulative. Oh, let's look this word up. Cumulative. Cumulative.
According to Wikipedia,
Cumulative. Cumulative. New Jersey. Whenever you see a thing that says X and Y are not the same length in a plot like this, it normally means that one of your X or Y is misspelled. In this case, I forgot that I changed date to an uppercase, so I had to spell date with lowercase, I couldn't find the variable. So that's that. Let's see, one more thing. So let's see how this works. Yowza. This is interesting. This little jump up right here, that's not a good sign. But of course, as I said before, notice the cumulative totals. They never go down. In the case of Casey, you can see where the curve started to flatten before going back up. The case with deaths, it's even crazier. Look at this. The first flattening was there, then this huge jump here. I don't know what happened here to really make that happen. But that is really strange. And now we're just going to take these two plots here and do an initial change. Very good. Hmm. Most interesting. Now, one thing we can do what's sometimes called a low S or low WES uh, fitted curve. Let's take a look and see exactly what we're talking about here. All right. Local regression or local polynomial regression, also known as moving regression, is a generalization of moving average and polynomial regression. It's the most common method initially developed for scatter plot smoothing, and low res, locally estimated scatter plot smoothing, and low WES, locally weighted, both strongly related non-parametric regression. Okay. So how do we do this? Well, what we do it is we go over here to our code over here. See if we got smoothing here. Smooth. We don't really need to accurate because there's only 1 day per week. Let's take this code right here. And again, all the code and the links will be in the description below. Yeah. We could of course, over here, for instance, at the code, but that's all right. We already got this. So actually, I think we need to see if we got it here. Yes, we do. What we're going to do is df2, daily cases, and this should be date. df, just modify some code. This is why you always want to. This is why you also want to keep your code meaningful descriptions and your project directories meaningful descriptions. Then we can come back and do it for this here in a couple of minutes. So does this work? No, it doesn't. No. So it is indexed. Let's see what happens. Excellent. That's not a prediction. No, of course not. It's got to be DF. So what we actually plot is this value right here. This is the new variables tacked onto the end of, of the data frame. Let's just take a quick look now at this and see what we really have going on here. Okay, so now you can see the predicted values. This is default. This is a span of 20.25. This is a span of 0.5. So all we do now is we come back down here. Let's say come up here and these mainly work with, note that these are cases only. So let's use our daily cases. Get back down here. My limited experience is that comma df colon date comma smooth as 0. And I didn't like something over here. Oh, I forgot the call function here. And now we have the default curve. Let's just do this. Let's just plot okay. Now you can see with cases how the various, so red is the 0.25 is the default, and blue that's kind of nice, but you know what, I hate to say it, but uh, let's just go ahead and okay. There's 25. So let's just change all these to red. Notice, of course, I'm using the basic plotting function in BaseR. No additional libraries, not even any no SQLite database. This is all pretty basic stuff, and you basically you can basically use the same code over and over again. Of course, you're doing the same type of analysis, the same type of COVID-19 data. But let's see something here. All right. This is the default uh, low as fit. Not bad. This should be 25. And we could do, let's just, which one's a better fit? This is the default. For this data, it's not that bad of a fit, actually. But 25, interesting, because it seems to be indicating um, a slight decline. 0.5 really flattens this out here. I personally prefer the 0.25. I think it fits the data just a little better, and there's not as much data below the line as was before. So all we have, so there's no point in then repeating the whole thing. This is going to be just bother this down here. Okay, date, daily deaths, deaths, just for the sake of convenience. Let's just see what happens. That's what. Well, this shouldn't make any difference, should it? Hmm. Hmm. Why isn't this running? Index is good. It doesn't like this for some reason. Hmm. Why doesn't it like it? You know, let's think about that for a minute. Let's move on with one I prefer is actually we actually need all this. If you can see an error up here, why I'm getting two different links in it, post a comment in below because I'm not sure what it is right now. This should look familiar. Okay, this should look familiar. It's the exact same code I used last night, but the analysis is the same type of data, so it doesn't make any difference. The only thing we have to do is change this to weekly, this to weekly, this to monthly, this to monthly, this to monthly. See how this runs? Run two plots. So here's New Jersey's cases by week. Looking really good in New Jersey. What you're under? Well, not necessarily, because if that number's 5,000, that means you're still averaging 2,000 to 2,500 cases a week. While deaths had a spike here. Deaths is looking good. This is well below. This is probably 250 right there. So the deaths are looking really good. See if this works. Monthly cases. Cases is still looking good compared to where, well, good grief. 20,000 cases. So you're probably 10 to 12,000 cases. Deaths. This is 1,000. For July, you had about 1,000. Well, that's not, you're actually doing pretty good. This is actually really good. With a week to go, we're probably not going to pass this one up. So what I'm going to do is this one up here. I'm actually going to comment that out unless I can figure out in the last 5 minutes what I'm doing wrong. Index, low res 25, low res. What's wrong with that? I don't know. Sorry, I'm not sure what I'm doing wrong there. That worked perfectly for the cases. It should work for the deaths also then. But let's just run the report we got so far and see what it looks like. Okay. The cumulative cases continue to decline. Cumulative deaths continue to decline. Cases, deaths, defaults, 25% looks good. Showing some decline here, a little there. 0.50 levels out too much for my liking. This kind of trends up a little bit. And like I said, since I'm not really sure what I'm doing wrong with the deaths, I'm going to have to think about that and maybe make a quick video about it once I got it figured out. Once again, you see the weekly cases. This is 5,000. So it's between, well, this is the total for this week. So this is maybe 2,500, 12 to 1,500 here. So this isn't necessarily very good yet. You know, over 2,500 cases a week. Deaths look good. This is 500. So this is 250. This is 250, 125, maybe 100. So while the cases are actually holding pretty good for New Jersey. A little bit of an increase, but there's really, well, 5,000, they're approaching a couple 2,500. Yeah, I still say that's pretty good. Deaths definitely look good for New Jersey right now. Obviously, there are still some deaths, but still, it's not bad. So I think that's will be all for this evening. Sorry I couldn't come up with an answer for that for the low as smooth fitted curve for the deaths. I scratched my head and didn't come up with it, but thanks so much for stopping by this evening, and don't forget to click that red button down the bottom of the screen and subscribe to the YouTube channel, and also like and share this video. We'll see you tomorrow night with another random state report.